Right now I'm gonna show you how to use the MIPS simulator, which is basically called SPIM, which is basically the reverse name of MIPS. The purpose here, and in most cases, is actually to see if you can simulate your MIPS assembly, right? And this is for the in-class exercise for our ComSysArch class. One of the first thing I want to make sure you are aware is on the left side here, once you open up the Qt SPIM, which is what is available on the SPIM main page. This is one of the simulator, the newest version. You see that there's a floating point register, which in this case, for our purpose of our exercise, we're not using it for now. And this is an integer register. And you can see that for the integer register, you see things like PC, which is a program counter, as we discussed in class. There's also the basically general purpose register that you can use for basically for everything, right? You can use this register based on the MIPS ISA that the in-class exercise provided document for. Right, and our exercise basically wants you to add two number, load the number and add them together. Right, the key here is make sure that you don't get, first of all, overwhelmed by on whatever is on the right side. Right, these are actually partially preloaded assembly that is there to make sure that it runs. Right, to make sure that it runs. Right now, I'm not really running anything. Right now, I'm not really actually including the part that we're trying to include. We're not loading our program yet. So in actually, if another thing is, if you click on this part, if you see it over here, right, you see the control of the simulator. You can run and pause, you can stop. And right now it's not running anything. So if you actually run, it would complain that the jump to the main function is not known because right now you're not loading your program yet, right? So essentially, when you see the location of your main function is a bunch of zero, as you can see here, right? The reason why there are a bunch of zero is you're not loading your assembly yet. So the simulator complains it to you that say, hey, I don't know where to jump to, right? So that's why you see an error when you try to run it right after you open, right? The other thing is you can look at the register, right? And you can clear. First of all, you can show the binary versus hex versus decimal, right? Might be handy if you want to look at the different representation. You can clear the register. You can reinitialize the simulator. Basically, this would reinitialize things. You can see the log at the bottom here that would say, hey, memory and register are clear, right? This is basically initialize everything. If you look at the register value, it's a bunch of zero, right? Let's say you have the assembly code that you want to run. For example, I took one of the basically one of the submitted solution to our in-class exercise, right? Look at this. It's basically it's a MIPS assembly, right? That contains, I'm gonna load, right? The value and it adds to number, right? And then syscall to actually finish. Right, I'm gonna load this particular assembly.asm. Right, asm is the assembly, the file that represents MIPS assembly that would do whatever you want them to do. This is your main function. Think about it this way. This is like your main function in C code, but it's basically written in assembly. So the first thing I can do is to click on file and load file. This would basically allow you to load the files, right? Over here, I can load in class1.asm, which over here, you can see that now the jump is, instead of to 0 over here, right? Jump to main is now at 004, 00024. If you look at this particular line, this is your first line in the assembly code. So if you somehow go back in the video a little bit and look at the assembly code, that's where the first line is located. And you can see the rest are essentially the rest of the code, right? The rest of the code. This is the value of your PC. This is the address of that particular line in assembly. These are the binary representation of the assembly code, right? If you then run, you will see that, okay, now things start to take value, right? There are changes highlight in red, right, that reflects what happened to the register. And the syscall basically means that, hey, I'm done, right? So basically this run to the finish of the program. It's a really, as I said, it's a really, really short program, right? So it runs and it adds to number, right? Over here is add A0, T0, T1, right? Over here you can see A0 is this, T0 is this, T1 is this, right? You are basically adding 10 to 3, and as a result, A0 is D, which is 13, right? So you change the representation to decimal, you see that you're adding 10 to 13, and you got result of into 4 or A0, which is highlighted right here, right? And basically that's it. How to use assembly. Basically, you write the assembly files in MIPS and you can click run. The simulator would actually run that code. And you can see the changes. On the left side here, you can see how the register value takes in, right? It takes in whatever you're writing, and you see the changes right here. And again, you can look at the hex and decimal number. And that's it for the demo today, right? If you have any questions, feel free to contact me either through email or through our Discord channel, and we will actually figure out are there any other things that might confuse you. Hopefully this helped quite a bit, right? One more thing, actually, this when you look at the text is the part where you see the code, right? That's where your code is located. That's anything you see on this pane right here is basically the memory side. Text is where the code is located. Data is where your data is located. So you can see the data segment start from address 1 and a bunch of zero here, and up to 10040000. That's where the user data segment. This is where the stack is located. It behaves similar way as the stack as we know it, right? And you can see the address would be on the left side, the value will be stored on the right side, right? And yeah, that's all. That's all, right? So you can see the code, you can see the data. And that's it. Thank you.